Hey guys, so we're going to continue solving quadratics by factoring. However, there's a couple special cases that if you can recognize these, they make your factoring life super easy. It's not a big deal if not. Notice the first one we're talking about is perfect square trinomials. So they're still trinomials. If you did not recognize that they were perfect square trinomials, you can still do the jingle. You can still do A times C, factor tree, sum of B. It'll still work out. However, if you do recognize that they're perfect square trinomials, you can just graph super fast. So let's come over here and notice that I have written out all of my perfect squares. For some reason, I decided to stop at 17. Who knows? So, because I was running out of room. Again, do we need all of them? No, not necessarily. I just want to be able to recognize that something is a perfect square. So if I look at our first example, a squared plus 2ab plus b squared equals the quantity a plus b squared. That means a whole lot of nothing. So let's look at this example. If I think I might have a perfect square trinomial, the first thing I want to do is I want to look at my a term and my c term. Now, 4x squared. What squared is 4? 2. And 36. What squared is 36? 6 times 6. And notice, it says twice ab. So if I double a times b, so 2 times 6 is 12, and I multiply it by 2, by gee golly, we get that positive 24. Okay, so that's cool. Why does that help us, Miss Romprey? Well, let me show you. So what I can do is normally when we factor, it looks like this, right? Well, what squared, what times itself gives me 4x squared? Well, we already said it's a perfect square. So 2, well, I got my x squared. So 2x times 2x gives me 4x squared. All right. And then what times what gives us the 36? 6 and 6. Now we do need to pay attention to our signs. Notice everything is nice and positive. So I leave it nice and positive. So 2x plus 6 times 2x plus 6. I have factored this. This is in factored form. Notice this looks a little bit different up here. What is this saying? A plus b. So the first term and this last term squared. Well, what does that mean? I'm multiplying something by itself. Well, we're multiplying something by itself. So this can also be written 2x plus 6 squared. So if you want to, actually I'm going to put that off to the side. Okay, because if we want to solve, because it does say factor and solve, so 2x plus 6, if we go to solve, I'm going to set it equal to 0. So subtract 6 from both sides. 2x equals negative 6. Divide by 2, x equals negative 3. Notice, they're the same thing. So we only have one solution. So on my graph, there is only one point that is an x-intercept. We have an x-intercept at negative 3. So our parabola, because remember this is a quadratic, okay, highest degree of 2, so that U shape only touches the x-axis once. We'll talk more about that later. Is that pretty cool? So again, if you didn't recognize that this was a perfect square trinomial, it's totally fine. You'd look at it and you'd say, okay, 4, 24, 36, factor out the GCF, and then you do your jingle. That totally works, all right? But if you recognize the A term and the C term are perfect squares, then you might be able to, cut short some of your work. All right, so this perfect square trinomial, everything was positive. Notice our second example, our middle term is negative. So what that means is, well, a times c is positive, but adding up to be a negative, so both middle terms have to be negative. That's what's going to happen this time. So let's see if we recognize that this is a perfect square trinomial. Well, what's our a term? What number can I write in there? Yeah, 1x squared. So 1 is a perfect square because what times what equals 1? 1. All right. And then we have 64. Well, dang, what is 64? 8. So 1 times 1 is 1. So when I go to set it up, I always set up my 2 parentheses, but if you recognize it, you can set it up like this as well if you like that way. So what times what gives me x squared? Well, 1x times 1x. No, you do not have to write the 1 if you don't want to. All right, what times what gives us 64? 8 times 8. Because remember, it's twice a times c. 1 times 8 is 8, and if I double it, I get 16. But wait up. This is negative 16. So since that's negative 16, I need to make both subtraction because negative 8 and negative 8 gives us the negative 16. So again, in factored form, you could write it like this, or you could write it x minus 8 quantity squared because we have 2 of them. Now, if you go to find the solution, what makes x minus 8 equal to 0? Well, 8 minus 8 equals 0. So our solution, x equals 8. All right, so let's go to try this next one. Now, something should be screaming at you right now like, wait, something's wrong. What's happening? Yeah, it's not set equal to 0, so that's not super helpful. So let's go ahead and set this equal to 0. So I'm going to add 28x to both sides. And I'm going to make sure that I write this in standard form. So I bring down my a term, 4x squared, and then plus 28x, and plus 49. Okay, so again, I see 4 and I see 49. I like those. Feel free to pause. If you're comfortable and you want to do it on your own, try it. Pause it real quick and then do it on your own. But I look at this and I see 4 and I see 49. I like it. I like it a lot. What times itself equals 4? 2. What times itself equals 49? 7. So if I go to set this up, what times itself is going to give me 4x squared? 2x times 2x. What times itself is going to give us 49? 7 and 7. And now the tricky part. I mean, not super tricky, but a little. Look at those signs. Everything's positive, so everything's positive. So if we go to find our solution, 2x plus 7 is equal to 0. So solve for x, subtract 7, divide by 2. X equals negative 7 halves. So you probably notice a pattern. Whenever we have a perfect square trinomial, we only end up with one solution. So our parabola, if we go to graph, the parabola only hits the x-axis one time. So the vertex of our parabola is going to be on the x-axis if we have a perfect square trinomial. That's just something a little fun. Don't worry, we'll get into that more later. Right now, I just want you focused on factoring. Again, when you're looking at these, if you do not remember that something or you don't recognize that it's a perfect square trinomial, that's okay. You can still factor it just like we've been doing. However, if I recognize it, I mean, I don't really want to do 4 times 49 and factor that. So if you can recognize it, it makes your life a little bit easier. All right, so now, again, we got to have a little application. So it says find the side length of the rectangle. Cool. So each rectangle has its area. I must have snagged this question because we only have one rectangle. But anyway, has its area written inside the expression. So this area is 289 inches squared. And the expression that represents the area is written below. Okay. So this represents the area. So to find my dimensions, I want to go ahead and factor it. So 49x squared minus 56x plus 16. Let me look at that in A and C terms. 49 and 16, those are both perfect squares. Let's double check and make sure this middle term works. So 49, that's 7 squared. 16, that's 4 squared. 7 times 4 is 28, and if I double it, we do get 56. Okay, cool. So I'm going to factor this real quick. So what times itself equals 49x squared? Well, 7x and 7x. What times itself equals 16? 4 and 4. And now figure out your sign. It is a negative b, so I make both of these negative. Fabulous. So I'm factored. Cool. What do we do with that? So I figured out that my rectangle is 7x minus 4 by 7x minus 4. That's not a rectangle. That's a square. My length and my width are the same. Sweet. Well, wait. What's 289? I recognize that from my list. 289 is also a perfect square. 15, 16, 17. Yeah. So 289 is 17 times 17. So if we go to find the side length, well, I know my length and my width are both 7x minus 4, and I know this is 17 by 17. So the side length, well, is 17 inches, because it's 17 inches by 17 inches. Now let's find the value of x. Well, if the side length is 7x minus 4, and I know that each side is equal to 17 inches, set it equal to 17, now I can just solve. So I'm going to add 4. 7x equals 21. Divide both sides by 7. X equals 3. So my value of x is x equals 3, and the side length, well, once I figured out that this is actually a square, then I could just figure out, oh, 289 is a perfect square. So the side lengths are 17 by 17, and our value of x is 3. So we found quite a bit of information just from the little bit that we were given. Again, if you don't recognize it's a perfect square trinomial, you can still do this. But multiplying 49 by 16 seems super gross, especially if you don't have a calculator. Okay, so everything I showed you so far dealt with perfect square trinomials. There's one other trick, and these are a lot easier to recognize because they look totally different. This is a difference of squares. So difference meaning subtraction. So they're always going to have subtraction. And notice, what's the other big difference? They only have 2 terms. So it's very easy to spot a difference of squares because you only have 2 terms. So if I go to factor these, what times itself equals x squared? X times x. And what times itself equals 121? 11 times 11. Now notice our rule. When it's a difference of squares, they have opposite signs. Because when we distribute it back out, that's the only way that the middle term would cancel out, is if they were opposites. So I make this a plus minus. If you didn't understand what I was saying, let me explain again. So remember, we can always distribute these back out to get to our original expression. So x times x, that's x squared, cool. X times negative 11, negative 11x. And then positive 11 times x, positive 11x. Wait, negative 11x and positive 11x, yeah, those cancel out. So then I'm just left with 11 times negative 11, negative 121. So that difference of squares, again, they're a lot easier to recognize from the beginning because they look different. So once you set it up, now we can solve. So x plus 11, what would make that equal to 0? A negative 11. x minus 11, a positive 11. So there's my solutions. I'm back to having 2 solutions or 2 zeros. Cool? All right, so let's look at the next one. 25x squared minus 81. 25 and 81, I like those numbers, perfect squares. So I'm going to set up what times itself gives me 25x squared. 5x times 5x. What times itself gives us 81? 9 and 9. And again, to cancel out that middle term, these must be opposite. So I'm going to make 1 plus and 1 minus. All right, so if you're looking at this going, whoa, what would the solutions be here? If you don't recognize it, set it equal to 0. 5x plus 9 equals 0. Solve for x. So we subtract our 9. Divide both sides by 5. So x equals 9/5. So that's 1. Now notice, when we have a difference of squares, they're opposites. So negative 9/5, this one I would add 9 and divide by 5. So negative and positive 9/5. So our solutions are inverses of each other. Cool? Okay, go ahead and try these out on your own. Let's see how you do.